We covered the three measures of central tendency, which are the mean, median, and mode. Now we'll cover the four measures of dispersion. Before we cover them, I wanted to talk about the idea of dispersion, or the idea of spread. Spread and dispersion pretty much mean the same thing. The idea of dispersion is the idea of how spread out different things are from each other. So think about the houses in somewhere like San Francisco, where the houses are all very close to each other. They're so close to each other, they look like they're almost touching each other. This would be an example of low dispersion or low spread between houses. The houses are not very spread out. They're very close to each other. So the dispersion is low, or in other words, the spread is low. I said this could be somewhere like San Francisco. If you go to a rural area where people own more property, you'll see that the houses are further apart from each other. Because in areas where people might have farmland, the houses would be farther apart from each other because people would be owning more property. So in this type of area, the houses would have more spread. I mean, there would be more spread between the houses. So you could say that this is high dispersion between houses. And I said that dispersion and spread pretty much mean the same thing, so I could have written low dispersion / spread between houses right here. I could have written high dispersion / spread between houses here, but I'll probably just use the word dispersion in this video, just so I'm not switching back and forth between two words. I said that spread and dispersion pretty much mean the same thing. Now what about cars driving on a freeway? Let's think about the speeds of different cars driving on a freeway. If the speeds of all the different cars are similar to each other, then that's low spread. I mean, that would be an example of low dispersion between the different speeds of the different cars on the freeway. So if there were 10 cars driving on a freeway at the same time, and their speeds were 65, 62, 61, 63, 65, 62, 64, and so on, that would be an example of low spread between the speeds of the different cars. I can even draw an example. Let's imagine that these are 10 cars driving on a freeway. And they're all driving. We could say that they're all driving on the freeway at the same time. And I'll write the speeds of the cars. I'll write the speed above each car. This car is driving at 65 miles an hour. This car is driving 63. Maybe this car is driving 66. I'll just write the speed that each car is driving. I'm just making up these numbers as an example of an example to show a low amount of spread or a low amount of dispersion. Notice how these speeds are all very close to each other. We have some cars going 64, some going 63, but the speeds are all pretty much between 64 and 66 miles per hour, or between 63 and 66 miles per hour. So these cars are all driving at very similar speeds. So there isn't very much dispersion between the different speeds that these cars are driving. You can even see the dispersion if we made a little graph like this. Maybe we'll make a number line that goes from, well, maybe I'll make the number line like this. Maybe I'll stop at 80. I'll put each car above its own place on this number line. Maybe I'll just make an X for each car. So let's see, we have one car going 63. So 63 is about right here. How many cars are going 64? We actually have 2 cars going 63. So there would be 2 cars going 63. So I stack these above each other just to show that these 2 cars, which I wrote out as X's, are both going 63. So they're stacked right above each other. We have 1, 2, 64s. Maybe, I guess 64 would be about here. There's 2 more X's. And then, how many 65s? 1, 2, 3. Those would all be right here. And then 166 would be out here. This X right here is supposed to be the car that's going 66 miles per hour. Notice how these speeds are all very close to each other. They're all clustered very close to each other on this number line. That's why this would be an example of low dispersion between the speeds of cars. Now let's look at another example. Maybe I'll put it over here. What if instead of these speeds, what if we had one car going 80 and another car going maybe 55. And maybe we have some other cars going at some other speeds. Maybe one car is even going 90 miles per hour. And one car is going very slowly at 40 miles per hour, which would be slow for driving on a freeway. We now have an example of 10 cars that have a higher amount of dispersion between their speeds. The speeds are now further apart from each other, so this would be a higher amount of dispersion between the speeds of the cars. And we can even see that if we made a number line. Now we have one car going 65 miles per hour. That car will be right here. We have one car going 80. We have one car going 90, so we have to extend the number line out even further. So we have 65, 80, well, I mean, 65, 80, 90, 66 would be right here. We have two 65s. 40 would be way out here. So the fact that we have to extend the number line shows that our spread is going up. We have 140 right here. We have another 66 and a 55. 63 would be about right here. And then 64 would be about right here. So notice how these speeds are spread out far apart from each other on this number line. They're spread out across this wide distance. So this is a high amount of dispersion between the speeds of the cars, unlike over here where we had a low amount of dispersion between the speeds because the speeds of the cars were all very similar and close to each other right here. Now, I wanted to give you another way of visualizing the amount of dispersion between us in a set of numbers. What I wanted to do was start off with a list of numbers with very low dispersion and then talk about how we could change the numbers to make the dispersion go up. These numbers have low dispersion because the numbers are all close to each other. They're all one apart. So if we took, well, first let's talk about how the gaps between each of these numbers is a gap of 1 because these two numbers are 1 apart, these two numbers are 1 apart, and all of the numbers are 1 apart. this is a gap of 1, this is a gap of 1, and this is a gap of 1, or a distance of 1. If we take one of these gaps and make it bigger, our spread will go up. So let's take this gap of 1 right here and make it a gap of 2. How can we do that? Well, if we want these numbers to be 2 apart instead of 1 apart, instead of going from 11 to 12, we'll have to go from 11 to 13. And then let's leave this as a gap of 1. So it'll go from 13 to 14. Maybe we'll leave this as a gap of 1, so it'll go from 14 to 15. Now what if we wanted to make the dispersion even higher? Well, if we take this gap and make this gap even wider, that would increase the dispersion. So if we change this to a gap of 4 or a gap of 5, the dispersion would go up. And if we took one of these other gaps and made it bigger, that would also raise the dispersion. For example, if we took this gap here and made it a gap of, let's say, 3 instead of 1, that would raise the dispersion. Let's try that. So these two numbers will still be 1 apart. We're saying that these two numbers will still be 2 apart. But now, these two numbers will now be 3 apart, so now it'll go from 13 to 16. And let's say that these last two numbers are still 1 apart, so it'll go from 16 to 17. So now we have a set of numbers with the lowest amount of spread, the lowest amount of dispersion. We have a set of numbers with a medium amount of dispersion, and we have a set of numbers with the highest amount of dispersion. So as we go from this list to this list to this list, the dispersion is going up. This list has more dispersion than this list, and this list has more dispersion than this list. Now, if we wanted to measure the dispersion, we would want to calculate some value that could actually show that this set of numbers has the lowest dispersion, and this set of numbers has the highest dispersion, and that this list has a dispersion in between, or you could say a medium amount of dispersion, I guess. And we'll talk about how we can actually calculate a value that can do that. But first, let's talk about a little bit more about why is it important to measure the amount of dispersion in a set of numbers, or in a set of quantitative data. Well, the reason why we want to measure spread is because if all we do is calculate a measure of central tendency, such as the mean, that doesn't tell us everything about the data. Let's imagine that I'm working at a job, and I'm working at a school, and my job is to record the final exam scores of a class of 20 students, and then report what I find about their exam scores to the principal of the school. And let's say I record their 20 final exam scores, and I find out that the mean of the class is 75%. So I found out that if I added their 20 final exam scores, and I divided the total by 20, and I got an average of 75, or a mean of 75. And then I go to the principal and I say, I found out that the mean was 75. The mean final exam score was 75. Well, the principal probably isn't going to be satisfied with just knowing the mean, because there's different possibilities that could be true. I mean, one possibility, or one extreme possibility, is that half the class earned 50s and the other half earned 100s. So if half the class got 50s and the other half got 100s, that would give you a mean of 75. And that would be an extreme high amount of spread, because half the class is way down here and half the class is way up here. The other extreme would be if the entire class got all 75. So if every student got 75%, that would also give me an average of, or a mean of 75. That would be a very low amount of spread. It would actually be no spread at all. If every student earned 75, meaning every student had the same final exam score, that would be no spread. So I said we have one extreme down here with all students earning 75%, which is no spread, and an extreme over here with half the students earning 50s and half of them earning 100s, which would be, that would actually be the maximum or the highest amount of spread possible. Now, realistically, the amount of spread between the students' final exam scores will be somewhere in between those two extremes, but the principal will still be interested in knowing where between those two extremes the class is. Is the class closer to the high amount of spread over here, or is it closer to the lower end of spread down here? In order for the principal to know where or how much spread there is between the students' final exam scores, I would have to calculate a measure of dispersion and give the measure of dispersion to the principal along with the mean. Now let's talk about how to calculate measures of dispersion with a set of data.